Hi, everyone. I'm Nitin Pathak. I'm a technical account manager at AWS. And I have an important question for you. Show your hands if you have conducted AWS well-architected review for sustainability. And keep your hands raised if you have conducted it at least twice. The hands will go down because we have seen people do not do these review over and over again as they continue to grow on their cloud IT journey. And this is what we're here to discuss. One of the key things is, as we continue to scale our cloud workloads, what is the environmental impact for the same? Secondly, what is generative AI's environmental impact on our sustainability? The AWS Silicon, how that is key for energy efficiency. And finally, how do we measure our sustainability and footprints as well? Now, first of all, cloud workloads are growing almost 25% year on year. Now, as we continue to grow and scale, oftentimes we tend to neglect or don't pay attention to the impact it has on sustainability. There are a few key aspects which will come over here. First, most efficient one, most important one, the higher carbon footprint. As we are increasing our workloads across various domains, it would mean that the carbon footprint will increase by just the numeration of the usage which is added over there. If that is there, the second part is there certainly will be increased operational costs as we continue to grow and evolve, which will be there. Our cloud workloads are growing, our costs will grow along with that. Now, when these things are growing simultaneously, there are a lot of times when we are not in line with the regulatory compliance. In many countries, many governments, they have standards on where we should be in terms of our carbon reporting, how much efficient we are in terms of our water usage, our scopes of emission. All these things needs to be in check as we continue to grow and evolve. And finally, a brand reputation impact. A lot of times we think, why do we care about sustainability? What is the reason for emissions? Well, a lot of times, our customers care about sustainability. Our stakeholders care about sustainability, and our government may also care about sustainability. It is important to have a measure that what are we doing for this environment, for this climate, and ensure that our workloads stay in line. We talked about the scale at which our regular workloads go. But there's another key aspect, which we have been dealing with in the past 2 years. We have kept saying that last year was a year of POC, and this year is a year of production in terms of generative AI. Well, if that's the case, and we continue to grow, there are impacts. The generative AI workloads which we are consuming are growing up to 300 to 500% year on year. But there are considerations. The considerations of the models which we are using, of the transformers we are using. While we use a standard GPT, training that could be around 1,200 megawatts per hour. And while we use a standard GPT, it's going to be 550 megawatts per hour. That's just one workload which we are consuming so much energy. And you're thinking what this will translate? On a standard terms, a 1,200 megawatt per hour energy will be approximately 150 houses. It can provide electricity for 150 houses for an entire year in the United States. If we take this number to Europe, it's almost 300 houses for an entire year. And in somewhere like India, it's 1,000 houses can be powered by the energy that is used to train a standard GPT. This is the consideration we need to do. But that's the problem. What should we keep in check with? How to get ahead of this? How to overcome these things? And we always go back to the sustainability well-architected pillar. In 2021, when AWS added the sustainability well-architected pillar, it was based on these 6 foundational best practices. These are the cornerstone for sustainability on how we should manage our workloads. Now, these 6 have been used for our reviews, for our attention on our cloud workloads. They will remain same while we are using our generative AI workloads as well. Has anyone heard of these? Has anyone been practicing any of these? Have any things where they have gone through any of these best practices so far? Where will they align? How we are selecting our regions as terms of usage? Are we doing a proper scaling for alignment to our demand? What are the data strategies which are in place? Are there hardware and services you're utilizing to the best impact and the fullest utilization? What are the software architecture practices we are using? Have you ever given consideration to how much energy a Python code will consume? And lastly, what is the process and culture of our company as itself? Are we doing a sustainability-first approach as we are building our cloud workloads? Well, on these best practices, the foundations come. And there are few low-hanging fruits which we can always incorporate. And there are things which we can do furthermore in order to enhance. Speaking of low-hanging fruits, the first one, the easiest one, which we say, over-provisioned resources waste energy. We have had this thing, the cleanest energy you can use is the one which is not used. It's the greenest energy available. That quote from our CTO does stand. It makes sense even now. The things which we can do easily over here is, first of all, auto-scaling. Use the flexibility of cloud. Do not provision what is required. It is the ability to scale things up as per your requirement. Utilizing spot instances. It's always good to consume something which is about to be wasted and utilize for your benefits. Utilize it for your cost efficiency, utilize it for your energy efficiency. Using serverless, things like Lambda, using these simple items in order to get your work done quickly, efficiently, will help you reduce your overall carbon footprint. And finally, utilizing the tools what we have in place for you. The AWS Compute Optimizers will continue to give you recommendations on what you should resize and resize your architecture so that you will get better usage and better efficiency. You're not wasting anything altogether. What will it lead to? If you're doing the right sizing in a standard way, you can get up to 20 to 30% reduction in your carbon efficiency and also your cost usage. That's a very quick and easy win, and certainly can be leveraged. Thus, always try to see where workloads are, revisit them, get a regular review over them, see where you're failing. And we are finding ways on how we can utilize the same in order to get a better efficiency for our workloads. Now, this is what you will be doing. But AWS is with you in this journey. Yesterday, Matt Garman also spoke on the keynote about our chipsets which we were designing. We always talk about the performance and efficiency of these chipsets, of Graviton, of Inferentia, and Trainium. And as we continue to grow, they have a major implication on your sustainability aspect as well, as they are extremely efficient in your power usage journey. On a standard practice, a Graviton processor is up to 60% more energy efficient than a standard EC2 of the same size and same computing power. Inferentia was built to be more energy effective in terms of using our inferencing aspects. And so much so that Inferentia 2 is up to 50% more better usage for our power consumption for an efficiency. And finally, Trainium. While we are training our resources, it will have up to 25% better efficiency in terms of what it will be to train our resources as per standard item. So when we are using either our standard compute or you're using our AI-based models or generative AI-based models, these things combined together can help you maintain the sustainability posture of your ITs. Another thing is the sustainable Gen AI architecture. We need to focus towards the training optimization, the inference optimization, and data management and data efficiency as well. We'll talk about the first two aspects. As we continue to use the models, we somehow, for our purposes, intended purposes, tend to utilize the models which we want to train by ourselves. And we want to get the data in the right way as well, get the inference and training for the same. Well, and there's always an aspect of using what is already available. We have a lot of pre-trained models, and we have a lot of pre-optimized models which are available with a SageMaker that you can certainly use and leverage. As you do it, you will see a measurable impact on your overall energy efficiency as you continue to do that. And the next part, which is somehow the most neglected aspect as we talk about the sustainability journey, is the data management strategies. There are a lot of times when we see there's a lot of data which is not being used for either our training or our inference purposes, but it's still there. Are we utilizing it? Are we looking back at it? Not just is adding cost and volume to our resources, it's also going to waste energy and consume resources from there. So keep a check of that. utilize the data lifecycle management policies, and see if you can reduce and remove as many things as possible. Because the data which is used for our training purposes is always there in petabytes and petabytes. There's a lot of data which is being used for the same. So try to reduce that as much as possible. Next is optimizing the data transfer strategy. With as many customers I've spoken with, I've worked with, I've always had this discussion. We are using a AWS region which is already powered by 100% renewable energy. We are using all the techniques we are saying. Where are we adding this? Where are our carbon footprint coming from? And the one thing which people do not tend to manage is the data transfer and the impact it has. We are building our workloads in US East 1, and most of our user base are probably in Europe, in Asia, in different places. And when they are working towards this, getting things sourced from all the way from America to a different part of the country, there'll be implication on data transfer. And there'll be implication on the energy and the carbon efficiency of the data transfer which will be added. So keep and check on that. Utilize alignment to demand, utilize the region selection in a way which is closer to your user, closer to your user base, so you omit these emissions which are coming from the data transfer parts. And how can you keep a track of the same as well? Well, AWS has aspects that can be useful for you. Have you used AWS Customer Carbon Footprint tool so far? Gone through it? For everyone's benefit, in your Cost Explorer dashboard, which you use to view your cost, there's always another option available for your AWS Customer Carbon Footprint tool. I recommend you take a look at this. See where your workloads are lying, how much energy efficiency are there, what kind of emissions you're going on with this Carbon Customer Footprint tool. And secondly, utilizing the CloudWatch metrics in order to be better at your efficiency. The CloudWatch metrics can be used as a great KPIs for sustainability. You get a chance to view how is your instances and resources being, what kind of utilization they have. You'll be able to see your data transfer network in and out to get a gist of, is it really necessary for your system? You'll get to see your memory consumption of these. Utilize those metrics which are available for you in order to get KPIs for your business and for the sustainability aspects as well. We keep mentioning that sustainability is nothing but an amalgamation of cost optimization and environmental responsibility. So combine these things together, and you'll get a better results. So to ensure that your workloads remain sustainable, and your IT, as you continue to grow with your business, with your scale, you remain sustainable with your efficiency as well, and keep a check on that. Please do take a look at some of our AWS Skill Builder course over here. And thank you so much for attending this. I will be there at the sustainability booth, which is right on the corner. If you have any questions on sustainability, AWS sustainability, how it can help you, please take a look at this. And thank you so much for attending.